Dear colleagues, let me introduce our next speaker, Professor Bernhard Eitel from Heidelberg University in Germany. Bernhard Eitel is a professor of physical geography who was serving as the rector of Heidelberg University for 16 years between 2007 and 2023. He is an internationally renowned representative of geomorphology, soil geography, and geoarchaeology, which applies the methods of geography and geosciences in archaeology. He pays special attention to landscape development, ecological circumstances, and the environmental management forms of local societies in arid areas. His research has been informed by multidisciplinary field studies in diverse places around the globe. Professor Eitel's publications include his monographic volume on soil geography and the co-authored book on landscape development in southern Germany. Both are widely regarded as seminal works in German-speaking geography and earth sciences. Professor Bernhard Eitel is a member of the German National Academy of Sciences Leopoldina and a corresponding member of the German Archaeological Institute. He was a member of the management group of the UNESCO International Geoscience Programs project Westerlies and Monsoons, Impacts of Climate Change and Variability on Dryland Environments, Hydrology and People. He has held distinguished positions, among others, in working groups of the International Association of Geomorphologists, the German Society of Geography, the GeoUnion Alfred Wegener Foundation, which is the Association of Earth Science Societies in Germany, and the Heidelberg Geographical Society, as I said, among others. He has served as president and governing board member of various international and German university alliances, including the League of European Research Universities. Bernhard Eitel's scientific work has earned a worldwide reputation. He has been awarded the Commander Grade of the Order of Academic Palms of the French Republic, the Farouk El-Baz Award for Desert Research of the Geological Society of America, and the Order of the Rising Sun in Japan. He has received honorary degrees and other distinguished awards from several universities in Europe and America. As the rector of Heidelberg University, Professor Eitel regarded Eötvös Loránd University as a distinguished partner. For all these merits, Eötvös Loránd University will award him tomorrow the titles of an honorary doctor and professor. We are very glad that Professor Eitel joined this event today and will deliver his talk under the following title: Desert Margin Areas and the Development of Early Cultures Towards the Neo-Deterministic Paradigm. Dear Professor Eitel, thank you for being with us. The floor is yours.
Thank you very much for this kind invitation. It's very difficult to see myself. Magnificence, spectabiles, dear colleagues, students, and young researchers, it's a pleasure for me to be here with you. And we had now a break, and now it's a scientific break to the wonderful presentation we heard before. Now I would like to introduce a little bit more drylands, in particular desert margin areas and the development, their impact in their development, the development of desert margin areas and their impact on early cultures. And finally, we will look a little bit, we have a perspective to the paradigms existing in the moment in science. Okay, first of all, we would have a look on climate changes. Climate changes. In the 19th century, we learned that climate is not stable. Before, people thought climate is God's given. It's stable. We learned that it's not stable. We learned about ice ages and further on more and more about climate variability. In the 20th century, we learned that humankind is a climate factor. And end of the 20th century, we learned, and the older ones here in the hall, they remember that global warming research was in the focus. So everybody focused periglacial regions, high mountain areas, looking on glacier melting and other features. But we learned in the 90s that global change research is also distinguished by hydrological changes in the atmosphere. So water in the atmosphere became more and more in the focus, not only the temperature, but also the hydrology of our planet. So, and with this perspective, drylands became member of the focus and are in the focus of international research. And drylands make up about 30% of the land surface on Earth. So these are huge, vast, extended landscapes, and they react very sensitive to hydrological changes in the atmosphere. That's a characteristic of these areas. And their ecosystem have a very fast reaction rate, even to weak changes. And of course, if people live in such regions, the impact on humans and on societies is very deep. In 2007, the German Working Group on Geomorphology wrote a memorandum about that. We should learn more about drylands. Do not focus only on glacier melting in polar regions and high mountains. A little bit smaller was the paper, but that was the main focus. And we introduced it into the UNESCO IPCC program. You heard about that, the monsoonal variability and the impact of people and societies. So we started internationally a reactive regions research program, and we wanted to implement reactive regions research in particular with a particular perspective on drylands, on desert margin areas, as an own component into the Earth system research. Now to this presentation. I decided to create 4 chapters. First of all, what is a desert margin area? Then I would highlight this along 2 examples, one within the Namib Desert in southwestern Africa, and the second one in the Peruvian coastal desert, the prolongation of the Chilean Atacama Desert in South America. The part 3 will be humans in desert margin areas and the adaptation strategies developing early cultures from the late Pleistocene until the mid-Holocene. And at the end, we will show how it fits into the paradigm pendulum and the system Earth research. It's a long and it's a dry road we have to go today, and I hope that we all will survive. You will survive my presentation. First of all, part 1, the margins of desert margin areas. If we look back, and if you look to textbooks, desert margins are mostly defined as lines. Maybe mean annual precipitation between extreme desert and semi-desert environments, or by Gradman and others, by vegetation cover, for example, 10% or so. So we are always looking for a line to separate deserts from semi-arid landscapes. But climate is very variable, and drylands react, as I mentioned already, they react very sensitive to hydrological fluctuations, to precipitation. And therefore, there is no generally accepted and clear and cognizable desert margin. You will find nothing in textbooks as far as I know. So, but modern dryland research shows that precipitation fluctuations in time and in space, and that's the crucial part, in time and space, it's a 4-dimensional perspective, lead to permanent shrinking and expanding of deserts, what we call a desert. We have no line, but we have permanently, because of the variability, we have permanently a shrinking and expanding of deserts. And therefore we come to a more precise definition, and that's in time and space. These are the desert margin areas. They are own spatial concepts. Desert margin areas remain stable with respect to precipitation variability during the years, but also over a longer time span, over decades up to several centuries. And you see here, the desert margin area in this graph is defined by hydrological fluctuations between the persistent extreme desert and the persistent semi-arid environments. And in between, there's a corridor. This corridor are the desert margin areas. And now I want to highlight with 2 examples why and how these areas are characterized by own geomorphodynamics, by own sediment times, and also by an own impact on humans living in this area. And as I mentioned before, we look to Namibia, and later on we will look to South America. We are here so you see the dry area, in particular in the southwestern part, in Namibia up to Angola. And we will look here, I want to highlight river end deposits. It's also a sediment type you will not find in textbooks. And that's really surprising because endorheic and endorheic drainage on the landscape is always in textbooks like lakes, in basins, and so on. Here we see that we have an endorheic drainage system and particular river end deposits as archives for hydrological changes. On the left side, you see the study area in northwestern Namibia, along the Skeleton Coast, a little bit east of the Skeleton Coast, Sand Sea, the Atlantic Ocean in the west, and the Etosha Highlands, more than 1,200 meters high in the east. And you see a drainage system, that's a drainage system of the Hoaneb River. River is not really true because it's an ephemeral river. Only during monsoonal summer rains, he gets in his upper catchment some water coming down to the desert. And the location Amersfoort is not a village, it's Amersfoort. It's a boorish name for a location in this area. This river came down and sedimented filled up his own valley with very fine-grained materials, silty materials and fine-grained sands. More than 12 meters in thickness, no gravels, no pebbles, in an environment of more than 1,000 meters in difference in altitude. Really surprising. When we saw it for the first time, we said, what a miracle! We cannot imagine how it can exist, how it can develop over centuries of years without any coarse material, not one single heavy rainfall event with heavy runoff, nothing. So these are river end deposits. That means that during the years, the river came down, sedimented always in the same position, a little bit further, a little bit left. That's the variability in the precipitation. And so he filled up the whole valley. And you see in the background, the Hoaneb, now a little bit incised presently, as you see it here as well. These sediments bury a gallery wood. So that's a highland, that's a highlight for every scientist finding wood in sediments. We can date, wonderful, radiocarbon and so on, wonderful. But we also have, and Heidelberg was one center of the developing of optical simulated luminescence dating, we can date feldspar and quartz grains, and we can date the sedimentation age. But the wonderful fact here is that we have two archives, two methods independently, and we can check both methods. And if we put all together the gallery wood, radiocarbon dated, and here you see three examples, three exposures with sedimentation data. I won't highlight it not in detail, but if we date the sedimentation, we see that the sediments of the Amersfoort silts over the length of several or more than 20 kilometers are deposited during the so-called Little Ice Age. That means from the European medieval times, about 1350 to 1850 AD. 1850 was the time with the lowest temperature since the last glacial maximum, about 18,000 years ago. And if we put all data together, and you see here now the sediments in a section, in a longitudinal section, you see 3 meters in thickness downstream, about 3 meters in thickness upstream, and in the central parts more than 12 meters. So deposition, our data showed that deposition started downstream, and shifted up due to an aridization. It became drier and drier until about in distance, until some 10 kilometers upstream and stopped. And then after Little Ice Age, about 1850, it became a little bit more humid, more monsoonal influence from the east side, from the tropical monsoon in the east, more runoff, and then erosion again. What we learn is that as cooler the atmosphere, as drier the desert margin area, and with the warming after 1850, it became more humid. First, keep it in mind, it's wrong what a lot of journalists say, that if we warm up the atmosphere, the desert will expand. We can show it all over the world. I highlight only 2 examples, the second one as well, that with the global warming, deserts are shrinking. If they expand, it's desertification, man-made desert. But it depends not on the precipitation, not on the hydrological situation in the atmosphere. Pars pro toto, one for others, the Amsport sills proves the concept of shifting desert margins, defining a desert margin area. And if you see a cross-section through the northwestern Namibia with the highlands, and you see the desert margin, and this desert margin shifted over the last centuries in a distance of about 40 to 110, 120 kilometers. That's the desert margin area. And that's very interesting that in common perspectives of earth scientists, also of geographers, that was not really recognized, and we always try to search for lines. Second example, we go to South America, you see the Andean mountains, and we are here in southern Peru, the prolongation of the Atacama Desert north of Chile, and you see in green colors the downcoming rios with the catchment in the semi-humid and semi-arid highlands, mouthing into the desert, sometimes crossing the desert till the Pacific coastline, but most in the parts ending in the desert, as well as situation as in Namibia. And when we came in this area for the first time, we saw loess. Everybody here in the hall, I think, learned about loess, about periglacial loess in the school, but that's desert loess. It's completely different. It's not different by the sediment, but it's by genesis completely different. Desert loess in the foot zone of the Cordillera Occidental, it's deposition and fixation, and it's about half a meter of desert loess, of dust sediments, needs a vegetation cover, needs grass. And grass needs about 150 or a little bit more than 150 millimeters mean annual precipitation per year in tropical landscapes. So this was a grassland. When we came for the first time with archaeologists in this area, we said, wow, because it's the best you can ever have in your life as an earth scientist if you discover something really new. You feel like an astronaut on moon. And it's exciting. So it was really, sorry for that, I'm an earth scientist, it was geoarchaeological. When we have been in the landscape, wow, desertless. We saw that, we dig in the dust, and we found at the loess basis, Muline species, as well as Culatus chiletensis granulatus species. These are snail shells. Wow, again, we had an archive we could date by radiocarbon. We dated it by radiocarbon on about 11,000 years ago. Wow, that's the beginning of Holocene. Oh, now we were like electric guys. Now we had the opportunity with the loess, or again, to use lumination dating. We dated the loess, and we found that it was sedimented between 11,000, exactly, it fits with radiocarbon data, with the radiocarbon ages. It was deposited between 11 and 4,000 years ago. And now we have been in this area. It was a humid period, so between 9 and 2K before the Christian era. I translate it in archaeological terms, not only because Laszlo Boré is here with us today, but also because it was a project we carried out together with archaeologists of the German Archaeological Institute. So we could combine and check our data with the artifact data of the archaeologists. So, and they showed us that the settlement, the first settlement in the area by the Paracas and Nazca culture occurred exactly about in the second millennium before Christ, with the aridization of the desert. With the end of the loess sedimentation, the expansion of the desert. What did the people? They focused their settlements on the river oases with permanent or with seasonal water supply from the high Andean mountains, whereas the quebrada systems, the local systems, felt dry, and they are dry up today. Now, on the central slide, it's difficult to see. It's not really clear. You see a line, a geoglyph, designed by the Paracas Nazca, crossing the quebrada system. That means that since the Paracas Nazca side, there was no significant runoff. Again, wow, no El Nino. The Americans were disillusioned because they always said Nazca, they suffered under El Nino and so on. I said, no El Nino, otherwise the geoglyphs would be gone. Geoglyphs exist, and they cross the local quebrada systems. So there must be a monsoonal impact about fluctuations in precipitation from the east, as we have seen that in other parts in the world, like in Namibia. And then you see here now a photograph out of a bullseye of a small aeroplane we used flying over our study area on the river oasis. It's a little bit like an sport. The whole oasis was filled up with fine-grained material. And if I tell you, you see here in the central parts, more than about 3 meters, only loess-like fluvial deposits, silty deposits, without any pebble, without any gravel, and it's more than 2,000 years old. Sedimented over more than 2,000 years. Wow! The Danube River, without any flood, over 2,000, it's we have no idea about that. A miracle? No, it's not a miracle. If you think about an aridization and step by step, river end deposits filled up with fine-grained material, the settlement area of the ancient cultures, as you see on the right side, where our archaeologists like digging in the fine-grained materials because it's not so heavy than in other things. And so it fits very well. People concentrated in the river oasis exactly in the river end deposits. So again, the aridization after the loess sedimentation, the aridization is confirmed by archaeological findings as well. And if we put now again all data, not only these two highlighted parts, all data together, we see that, you see here, the steep environment. And again, remember, in this steep environment, more than 4,000 meters high, more than 2,000 years, no pebbles, no gravels. It was really dry here. We see that the desert was really small until about the second millennium before the Christian era. Then it became, during the Nazca time, Paracas and Nazca culture, more and more drier. The desert expanded, and then we know that during the medieval times, it was a little bit more humid again for a short time. In the Little Ice Age, it was really cold and really dry. And then at present, we would like that more or less in this area is the present desert margin as a line defined by mean annual precipitation, more or less 50 to 100 millimeters in annual precipitation. Again, a desert margin area with a steep impact, deep impact in the on human cultures. What do we learn? You can you know Wilhelm Busch, and it's I think some of us learned about him some lessons. We learned today that desert margin area possess an own geodynamic regime. They are an own spatial unit in system Earth research. But also we could learn, because of their high reaction rate, that we have here an early warning system if we heat our atmosphere and bring more and more humidity in the atmosphere. We can go to desert margin areas to study the reaction of deserts. And that's even more precise, as we can say, because we have more sediment archives. It's more precise than looking on glaciers, which are individual ice corpus. For humans, desert margin areas are high-risk environments, that's clear. If you have more water, you live better than if you have less. But the interesting fact, and that's now part 3, the interesting fact is that all early cultures, all without, as far as I know, all earliest cultures with script and so on, earliest cultures developed in drylands, and in particular, most of them in desert margin areas. Why is that? Because of their adaptation efforts. Such areas with a high reactivity cause high reactive reactions. So they have a culture, they have always to react on the desert margin ecosystems. They change within decades. Within decades they can change. We saw it in the bogs, in the highlands of the Andean Mountains, that the changes happened within decades. We follow now the third part of the hypothesis that cultural development is triggered by adaptation efforts. I saw the blastic area. So officially the Anthropocene is killed by the international geological stratigraphic community. So it will not come. But perhaps we have a cultural stage after the Iron Age, the Carbon Age. It's better than plastic because we see life-inspired engineering everywhere on Earth, and more is based on carbon. But what happened here at the late Pleistocene about 15,000 years ago? We have an accelerated cultural development, but the Homo sapiens lived since more than 250,000 years. What happened? What's new? That's the geoarchaeological key question. Again, 2 spots. If we look to the global temperature curve, we see about 12,000 years ago, the warming with the beginning of the Holocene. It started earlier in the late Pleistocene. And we see the second mark, the milestone landmark we will focus is the Holocene ELTE thermal about 7,000 years ago. That was the warmest peak in the Holocene. Today, we are more or less in the same level. But you see also 1850, the little ice age, it was as cold as it has been since the late Pleistocene. And we will focus now on the warming and of you see the expansion of the deserts and the global aridization with the cooling after the Holocene ELTE thermal. That means we look on the Neolithic, on the first settlements and the beginning of the Neolithic, and we look on the urban turn. These are the 2 spots. And we look back. We look back to the last glacial maximum. And please keep in mind that it's also surprising sometimes. It's so clear, but nobody thinks about that. It was a very cold Earth. A very cold Earth is an Earth with a very dry atmosphere. A very dry atmosphere causes very sparse woodlands. There are no trees everywhere. In the mid-latitudes, you have tundra ecosystems. And in the center, in the inner tropics, you have a patchwork of rainforests. You have no big rainforest. Rainforest ecosystem is a young Holocene system. And you see in Africa, for example, in the inner tropics, there were huge grasslands. Wonderful for hunting, wonderful for the people. That's the reason why a lot of the Mesolithic people lived and the Paleolithic and Mesolithic people lived in the tropics. It's not so easy for us to live in the tropics. Biologists and our physicians know why. And now, that was a semi-arid area during the late glacial maximum. And now it became warmer and warmer. The woodlands expanded, and the game shifted to the becoming more and more moister deserts. The deserts became grasslands with game, and people followed out of the woodlands, expanding woodlands. And you see it here. Now for the first time we have a green world, and we become a world, we will get a world with more and more woodlands. Also, please look to the Mediterranean. In the Mediterranean, the woodlands expanded and pushed the people out, and the shrinking deserts pulled them because of favorable grasslands. That's really surprising. And now keep in mind, you have a lot of people in high reactive, hydrologically very sensitive areas. They are all, or most of them, in high risk areas. That's new. That's new in Earth's history. So the greening of deserts culminates in the Holocene ELTE thermal 7,000 to 8,000 years ago. And you see the reddish part. We go now to the Levant corridor. The oldest settlements occur there. And you see that people were pushed out from the Mediterranean, from the central Mediterranean, to this part, because there they got wonderful, for the first time, wonderful grasslands. Not in the Mediterranean themselves. There was a steppe environment before, and now it was a woodland. It became a woodland. And if we go now to the Levant corridor, we find about 14,000 years ago, in the Wadi al-Natuf, on the west bank, for the first time, the Natufians, for the first time, settlements. So hunters and gatherers settled down, and they developed step by step over the next centuries and some millenniums, over Göbekli Tepe in Turkey and Syria. They developed more and more the Neolithic agriculture. We detected these first settlements in our institute, a team of Dr. Hecht, with electrical resistivity. We prospected under the ground. You see other methods here, and archaeologists excavated the sites, and they found exactly this process in their artifacts. Now towards the Holocene ELTE thermal, the second one. It was not the push and pull in the desert, but now it was push and pull in the desert to most favorable parts. Because with the Holocene ELTE thermal and the drying, because it became more and more cooler, deserts expanded, for example, the Sahara as well, and people concentrated at the upper Nile River Valley, not downstream at the mouth to the Mediterranean Sea, and again also in the western part near Timbuktu, in the Niger knee, as well as in Mesopotamia, or in the Upper Indus Valley. Colleagues from Cologne, and I took this just as one example, investigated in the western Egyptian desert the development of the settlements, of the hunters and gatherers, and you see to the right side, with the aridization of the desert, people concentrated along the Nile River. For the first time, there was now a population which was very concentrated at favorable parts. They developed at different sites, they developed diversified societies, cultural differentiation took place. The Bronze Age started with the development of cities for the first time. And if you look on the world map on top, you see that even in the Gobi Desert in China, it was the same. Interesting fact that the first Chinese cultural spot was in the west and not along the east coast in China as well. You see here the expansion of the Neolithic and the first settlements, and here in this part, the urban turns, the development of early cultures. So, final part, 4. Until Darwin, we live in a time where the deterministic paradigm prevailed. Until Darwin, it was accepted, and now I quote Martin Rodwig, that the geologist's new scientific knowledge was confirming and even reinforcing the belief in the overarching and providential designfulness of nature. Nature was designed by God, and it was given by the Bible. Darwin stands for another explication, and I quote again, for the apparent designfulness of organisms as a purely natural product of natural selection, which dramatically undercut the plausibility of this part of the traditional argument from design. This idea from Darwin was taken up by Friedrich Ratzel. He brought it into geopolitics. You know that it was that it ends not in a really good way, but in a perverted way. But he said that even location and space play a central role for life. He brought it into geography. And Eötvös Huntington, under the Second World War, he followed up his mission to determine the process by which geological structure, topographic form, and the present and past nature of the climate have shaped man's progress, molded his history. That is natural determinism. The Second World War cut this tradition. And Anglo-American archaeologists focused more and more the anthropogenic argument that the will of an independent human shape his future and his environment. And with the rise of the social sciences back and under the influence of Max Weber, who wrote famous articles at the end of the First World War, which were taken up after the Second World War, and with the social sciences, humans became the main factor, as we see, for example, in the anthropogenic also. People are coining the future. People are in the central part. And we all use the term man and environment. That's for me terrible, because we separate humans from nature. We are rooted in both paradigms. Either nature is shaping the world or man, humans. But in reality, it's neither the one nor the other. Because we know, since the Club of Rome in its papers more or less propagated in the social sciences, but we know in particular from academic system Earth research, we know that man and environment interact. They are interacting components of one system at a certain locus on space-time information coordinates. Isar and Zohar formulated this about 20 years ago in a wonderful way. We are part of the Earth system, both together. We cannot separate that. That's the neo-deterministic way, and we saw it in the desert margin research. People coined the oasis. People shaped or influenced climate and the environment by development agriculture, by the development of irrigation, and so on. But anyway, they lived under the influence of the Earth system, of other components in the Earth system. The development of early cultures in particular, and the differentiation of cultures, different adaptation at special places, was triggered by climate fluctuations, causing environmental changes after the last glacial maximum until the subboreal period. So desert margin areas played a significant role in the development of early cultures. And meanwhile, humankind seems to coin the development of system Earth. That's the Anthropocene debate, which is solved by the stratigraphic community. Anthropocene is a political term and not a geological term. We can think about carbon-based cultures like Iron Age or Bronze Age or something else, but that's another way, other debate. Climate-sensitive desert margins, we know now, are early warning system, I mentioned that before, in the system Earth research. So, that was the summary. It was a dry presentation, and therefore now 2 slides here, or 2 photographs with rainfall in the dryland. I hope that you survived. As far as I can see, it's a fact. And köszönöm, I thank you very much.